Hello student, I am Dr. Sinha, Professor of Chemistry. Today I am going to discuss concept of acids and bases. There are two main concepts of acid and bases. First is Arrhenius concept of acids and bases, and second Lewis acid and bases. I will discuss both today only, both concept, and third one also I will discuss, that is the Brown-Steady-Lowry acid and bases. Three concepts are there, then I will discuss all three concepts. First, Arrhenius concept of acids and bases. Second, Brown-Steady-Lowry acids and bases. And third one, Lewis acid and bases. Okay. First, I am going to discuss Arrhenius concept of acid and bases. According to Arrhenius theory, acids are substances that dissociate in water to give hydrogen ions, that is the H plus aqueous hydrogen ion, and bases are substances that produce hydroxyl ions, OH minus aqueous, means substances which produces H plus ion in water is called acid, and substances that produce hydroxyl ions, OH minus aqueous, that is called bases. The ionization of an acid, as for example HX, capital X, HX, the ionization of an acid in a common way we can tell HX aqueous, that we can represent like HX aqueous, AQ. HX aqueous, it will dissociate as H plus aqueous plus X minus aqueous. HX will break in water as H plus and X minus. Okay. And after that, what will happen here? Important things here, that this H plus ion, HX, breaks into H plus and X minus. Then this H plus again it will react with you can say water, because you are dissolving in water. HX, you are dissolving in water. Then this H plus ion will react with water and it will produce H3O plus. Okay. Then in water, HX if will mix with water, then it will form HX plus H2O. HX plus H2O means it will give H3O plus X minus. This is the situation. HX means acid, maybe HCl, HBr, HIE, like that way you can understand. Then this HX reacts with water and it forms H3O plus, means with H2O, H plus will attach. It will form hydronium ion plus X minus. And this proton, H plus, is also called a proton. A bare proton means H plus is very reactive and cannot exist freely in aqueous solution. Thus, it bonds to the oxygen atom of solvent water molecule to give trigonal pyramidal hydronium ion, that is called H3O plus. This structure is trigonal pyramidal and it is called hydronium ion H3O plus. Okay. In this, can say here we will study, or we will you can say use H plus and H2O. H plus and H2O interchangeably, means that can be interchanged. H plus and H3O plus means hydronium ion interchangeably to mean the same, means hydrated proton, that is called hydrated proton. Okay. A base molecule, same way, now I told about the acid. Okay, that in water it forms hydronium ion plus X minus. HX acid will form a hydronium ion and X ion negative. Now think for the base. Base also will behave same way. Similarly, a base molecule like MOH, capital M, MOH like NOH, KOH, in a general way you can write MOH. Then MOH ionizes in aqueous solution according to the equation. What equation is there? MOH, it will give M plus OH minus. M plus OH minus. M aqueous and OH also aqueous. The hydroxyl ion means OH ion. The hydroxyl ion also exists in the hydrated form in the aqueous solution. Arrhenius concept of acid and base, however, suffers from the limitation of being applicable only to aqueous solution and also does not account for basicity of substances like ammonia, which do not possess a hydroxyl group. That is the weakness of Arrhenius concept of acid and bases. Weakness. What is the weakness? Then two weakness I told you. First weakness, that it will apply only in water. Arrhenius concept of acid and bases suffers from the limitation of being applicable only to aqueous solution. Only in water it will work. And second, does not account for the basicity of substances like ammonia, which do not possesses hydroxyl group. Ammonia is base, but ammonia NH4 plus, that is a NH3. NH3 has no OH, but it is a base. Then there is no explanation for that. Then and also this Arrhenius concept works only in water. When you will dissolve in water, only then it will work. Then this is the two limitation. Then because this concept holds goods only in water, and second, it will not tell why ammonia, substances like ammonia is bases which do not possess a hydroxyl group. Okay. Then this I have told about the Arrhenius concept of acid and bases. Actually, we are telling about the acid and bases here because these acid and bases that will ionize in water and it will make these things equilibrium. Okay, with unassociated acid, it will make equilibria. That's why we are telling first about the acids. What are the acid concept? After that we will come for the this equilibria. After knowing about the acid and bases of different concept, we will discuss about the equilibria, how they are maintaining the equilibria. Okay. Then now I am going to discuss the Brown-State Lowry acids and bases. Another concept that is the Brown-State BRONSTED, Brown-State Lowry, LOWRY. Both are scientists, chemists. the brown state, Lowry acid and bases. Then what is this? This theory what tells? Now understand minor change is there with Arrhenius, and this little change is there. What is change? That you have to understand. The Danish chemist, that is the Bronsted, and the English chemist Thomas M. Lowry gave a more general definition of acid and bases. According to the Bronsted-Lowry theory, acid is a substance that is capable of donating a hydrogen ion. Okay, here important thing is that according to the Bronsted-Lowry, acid is a substance which donates a hydrogen ion, and bases are substances capable of accepting the hydrogen ion, means H plus. See, this is the only, both are related to H ion. Substances which are capable of donating H ion, that is the acid, and substances which are capable of accepting H ion, that is the base. Here no concept of OH, no question of OH, both are related to H, which donates H plus, that substance is acid, and other substance which accept H plus ion, that is called base, no OH, according to the Bronsted-Lowry concept. Only H function as acid as well as base. Substance which donates H plus ion, that is called AC, and the substance that accept H plus ion, and that is called base. Okay, means here importance has been given to H ion, in H ion, H plus ion. Okay, this is the very, very important things. In short, acids are proton donor. We can tell in short, acids are proton donors and bases are proton acceptors. Okay, here I am giving one example. Okay, consider the example of dissolution of NH3 in H2O. NH3 in H2O. NH3 means ammonia, which actually Arrhenius concept failed about this why ammonia is working as a base. But now here you can understand, you will get explanation. Okay. Then now just to consider that dissolution of ammonia means NH3 in H2O. Okay. Then equation, how will you write? Then NH3 plus H2O. NH3 is dissolved in aqueous, AQ, okay, plus H2O. H2O, you know, it is liquid. Then NH3 plus H2O, okay. Then here what will happen, that NH3 will accept one electron from H2O. In H3 you have dissolved in water. In water H is there, H2O, H plus OH minus. Then this H plus will be accepted by NH3, and it will form NH4 plus. Then see, NH3 is accepting one hydrogen, one proton, H plus. That's why it is forming NH4 plus. Okay, and this is called NH3 converted into NH4 plus. Then NH3 was base. NH3 was base. Now after accepting H plus, it is converting into conjugate acid, NH4 plus. Then according to the definition, substances which accept proton, that is the base. Then here you can see NH3 is accepting H plus. That's why NH3 is a base, or it, and after that it will form NH4 plus. Then NH4 plus is called conjugated acid. And H2O, what happened to H2O? Then H2O lost H plus, means donated H plus. Then now after donating, only OH ion is remaining. OH minus is remaining. Then now H2O, which was here B, because H2O lost one electron, it donated one electron. That's why H2O is acid. This is important here. H2O donated one electron to whom they have given? Then they have given to NH3. Then H2O, after donating one proton, it converted into OH minus, aqueous. Then this OH minus aqueous, that is a conjugated base. Means after donating one hydrogen, only OH is remaining. Then it converted, it is called conjugated base. Means after accepting the hydrogen, it formed the NH3, proved that it is the base, because NH3 accepted hydrogen, and after the accepting hydrogen it formed NH4. Then it is called acid, because it accepted, NH3 accepted hydrogen, then it became a base. NH3 is a base. It is proved how? Because it accepted hydrogen. That's why it is base. NH3 is base because it accepted proton and it formed NH4. Then NH4 plus, that is called conjugated acid. Okay, and H2O, after donating H, it proved that it is the acid because it has donated one hydrogen, means proton, and it formed OH minus. Then this is called conjugated base. After losing H ion, OH ion is called conjugated base. And after accepting one proton, NH3 became conjugated acid, NH4. Okay. Then this concept is given by the Bronsted-Lowry about the acid and bases. The basic solution, but here in a simple way you understand, base forms acid. Base form acid, that is called conjugated acid, and acid form bases, that is called conjugated base. Very simple way, there is no question of confusing. Base, after accepting H, forms acid, that is called conjugated acid, and acid like H2O, donated hydrogen, then acid becomes base, that is called conjugated base. Okay, product side, you can write this conjugated acid and conjugated base. The basic solution is formed due to the presence of hydroxyl ion. Okay. In this reaction, water molecule acts as a proton donor and ammonia molecule acts as a proton acceptor and are thus called Lowry-Bronsted acid and base. Okay, respectively. In the reverse reaction, what will happen? Means think from the product to reactant, that side you will consider. In the reverse reaction, H plus is transferred from NH4 to OH. Okay, in a reverse reaction, H plus is transferred from NH4 plus to OH. In this case, NH4 plus acts as a Bronsted acid because NH4 is losing. NH4 plus, it can lose one H plus. Then that time NH4 plus, when it is losing one hydrogen, means one proton, then that time, because it is losing proton, then that time it will function as a acid. Then NH4 plus acts as a brown state acid, while OH acted as a brown state base, because OH accepted one proton. That's why the term conjugated is used, because it can change to acid, it can change to base also. Acid also, base also. In the beginning you have seen NH3 plus H2O. Then NH3 accepted and it will form NH4. Then that time NH3 was base, now it became acid. And H2O donated H and became OH. Okay, then NH, because H2O donated H, then it, after the donating, it proved that it is the acid, and OH is formed. But again, this OH minus and NH4 again can react. Transfer is possible. Then H ion will give to the OH. NH4, well, they will donate the proton. Then now NH4 plus will behave as a acid, and base is accepting that proton. Okay, then OH will behave as a base. Okay, this you should, that's why the term conjugation is used. Okay, then this I have told about these things: brown acid and base. Okay, the acid base pair that differ only by one proton. The acid base pair that differs only by one proton is called conjugate acid base pair, because they are differing only by one hydrogen, one proton. Okay, then it is called conjugate acid base pair. Therefore, OH minus hydroxyl ion is called the conjugate base of an acid, that is the H2O. OH minus is called the conjugate base of an acid, means H2O, and NH4 plus is called conjugate acid of the base NH3. H is there differing only by H. NH4 plus is called conjugate acid because it is donating. Or it can donate. Then NH4 plus is called conjugate acid of the base NH3. If brown acid is a strong acid, then its conjugate base will be weak base, opposite. This is again important things. If brown acid is strong, then this acid will convert to the base, then base will be weak. Then its conjugate base will be weak. Its conjugate base is a weak base. If acid is strong, then base form will be weak base. And reverse way, vice versa, means for the acid same things. If acid is weak, then its conjugate base will be strong. Okay, you have seen H2O. H2O is a weak acid. And OH is a strong base. Correct? NH3, you have seen. Then NH3 is a strong base. But acid NH4 plus is a weak, opposite. Okay, opposite. If acid is strong, then it will form conjugate base will be weak. If acid is weak like H2O, then conjugate base will be strong. It may be noted that conjugate acid has one extra proton. Here, these important things, it can be noted that conjugate acid has one extra proton and each conjugate base has one less proton. One less proton. Okay. Acid has, again you listen carefully, conjugate acid has one extra proton like NH4 plus, NH3 accepted H plus, then it has extra proton and each conjugate base like OH, conjugate base has one less proton. Okay, one less proton. This is important thing. Now consider another example. Consider the example of ionization of hydrochloric acid in water. Hydrochloric acid in water. Then here what will happen? HCl is strong. HCl acts as an acid by donating a proton. Who will take proton? H2O, because HCl you have added in water. Then HCl function as a acid, and who is taking H? Then H is going to taken by H2O. H2O is taking that H plus. Then it will form hydronium ion. Then see here, HCl donated hydrogen proton, that's why it is acid. Then Cl is remaining, chloride ion, then it will be base, and this base will be weak base, conjugate base Cl, and H2O has taken high proton, it formed it then H2O, because it is taking H, that's why it is behaving like a base, and then it is a big base, but now it is forming H3O, conjugate acid. Okay, then here what you have seen, H2O is functioning in both way. H2O is functioning as weak acid and weak base. Okay, it is functioning as a weak acid and weak base in both way. H2O is a weak acid as well as weak base. This is very, very important things. Here it can be seen in this equation, in this reaction, that water acts as a base because it accepts the proton. The species H3O is produced when water accepts a proton from HCl. Therefore, Cl is a conjugate base of HCl. Okay, and HCl is the conjugate acid of base chloride ion, reverse way. Okay, HCl, H plus Cl, then that will become conjugate base. Again Cl, when it will take, then it will be conjugate acid. H, after donating, Cl is forming, that is the base, and Cl again can take H, then it will form acid, then that is a conjugate acid. Both are conjugate base and conjugate acid. Same way H2O, if it will donate H, that I am already told you, acid. When it will donate accept H and it will form hydronium. Then C, because it is accepting hydrogen, then base, and it is forming H3O, then that is the conjugate acid. Again they can come back also. After losing H3O, it can, that time it will behave as a acid, because H3O plus is there, H3OH plus, they will donate. Then it will, because it is donating, then that time it will function acid, and OH will accept that this hydronium ion, they will donate, and who will take that hydrogen? Then this things H2O will take. Then like that way, when it will donate, that time acid, when it will accept, that time base. Both are called conjugated acid and base. The, the species H2O is produced when water accepts a proton, H3O. H3O is produced when water accepts a proton from HCl. Therefore, chloride ion is a conjugate base of HCl, and HCl is the conjugate acid of base chloride ion. Similarly, H2O is a conjugate base of acid H3O plus, and H3O plus is a conjugate acid of base H2O. Okay, all are differing by only one proton, and both are called a strong acid and a conjugate acid and conjugate base. And a strong acid will form big base, and big base will form a strong acid. Okay. Here already I told you, it is interesting to observe that dual role of water as an acid and a base. In case of a reaction with HCl water, water acts as a base, while in case of ammonia, it acts as an acid by donating a proton. Okay, ammonia and water, what will happen? Ammonia will take an electron, then ammonia is base and water is giving a proton. Ammonia is accepting proton, that's why it is a base, and water is giving a proton, that time it is acid. Then water has a dual role, that I have told you about the these things, Brown-Steed-Lowry concept of acid and bases. Now third concept, that is the Lewis acid and bases. Lewis acid and bases. Here you can see what happens. Here again it is very interesting, Lewis acid and bases, and this actually is a means you can tell a very important concept, and this applies for all, everywhere it will work, this concept. Okay, because it is based on electronic concept, also electronic concept, it is based on electron. Here acid and base is the substance where there is no H and no OH. There is no role of H and OH ion. Okay, then whose role is there? Then here role is of electron. Who is giving electron and who is taking electron? Okay, but this will work everywhere. Then G.N. Lewis in 1923, Lewis spelling uses Lewis, Lewis. G.N. Lewis in 1923 defined an acid as a species which accepts electron pair, that is acid. A species that accepts a lone pair, means 2 electron, accepts a lone pair, that is called acid, and base which donate an electron pair. Okay, this is the acid base concept, which acid as a, again you listen, that an acid is a species which accepts electron pair, and base which donates an electron pair. As far as bases are concerned, there is not much difference between Brown-Steed-Lowry and Lewis concept. Okay, in case of a base I am talking about, as far as bases are concerned, there is not much difference between Brown-Steed-Lowry and Lewis concept, as the base provides a lone pair in both the cases. In Brown-Steed also OH minus is there. OH minus means negative. Then there also they are donating electron. And here also, in this concept also, it is donating electron. That's why both are bases. Means Brown state base concept is okay. Here also electron they are donating, there also electron they are donating. Okay, as the base provides a lone pair in both the cases. However, in Lewis concept, many acids do not have a proton. Okay, many acid they will not have a proton H. Despite that they behave as a acid without H. How? Then again according to the electronic concept, because it will accept a pair of electron. Base will give base will donate a pair of electron, and acid substances which will accept a pair of electron, that is the acid, and substances or species which donate electron, a pair of electron, that is the base. Then acid, you can see example, I will tell you. A typical example is a reaction of electron deficient species like BF3, boron trifluoride. Boron trifluoride BF3 with NH3. This reaction we can tell BF3 plus NH3. Then BF3 is electron deficient. They lack electron. Octet is not completed. Octet is not completed. Then BF3 is electron deficient because they want electron. And ammonia, NH3, it has extra lone pair of electron. NH3 has one electron pair, means 2 electron is extra. That is called pair of electron on NH3. Then NH3 we will see, then 3 H bonds are there, then 2 into 3, 6 electron. Then 2 electron is remaining on the nitrogen. Total 8. For one bond, 2 electron is required. To make one single bond, 2 electron is required, minimum, single bond. Then 3 bonds are there, NH3, NH, NH, NH. Then 6 electron. Then 2 electron will be extra, that is called pair of electron. That is a pair of electron on nitrogen. And BF3, again we can see, then only 6 electrons are there. B and F bond, B and F bond, B and F bond. Only 6 electrons are there. 2 electrons are not there. They are not octet is not completed. Then now you can understand this ammonia, nitrogen has lone pair of electron in ammonia, that will donate to boron. Boron will accept. That's why ammonia behaves as a base, and BF3 which accept the electron, a pair of electron, that function as a acid. This is the example I have told you. The important example, and question is asked also. BF3 does not have a proton. BF3 has not a proton, but it is an acid. BF3 does not have a proton, but still acts as an acid and reacts with ammonia by accepting its lone pair of electron. And then we can write BF3 plus NH3, and product will be BF3 NH3. In the between the two, a pair of electron will come. BF3 NH3, both you can write together, but in the middle 2 electron will be there. Okay, and that 2 electron in N is giving to boron. Boron will accept. Then BF3, 2 electron in the middle, NH3. You can write like this way. Electron deficient species. Other examples I am telling you, just you always remember, because many questions are asked only on Lewis concept. Okay, Lewis acid and bases. Then other example I am telling you, electron deficient species. AlCl3, aluminum trichloride. Aluminum trichloride, CO3 plus cobalt cobalt 3 plus, cobalt 3 plus, CO3 plus, Mg2 plus. These are the example of electron deficient. Plus means electron deficient. Okay. Then AlCl3 again only 6 electrons are there. Octet is not completed in AlCl3. And CO3 plus, obviously 3 plus is there, then they will accept the electron. Mg2 plus again, they lacks electron. Plus means lacks electron, etc. And these can act as a Lewis acid. While a species like H2O has a 2 lone pair of electron, not only one, 2 lone pair, because H2O, then only 4 H2OH, 2 bond is there, means 4 electron. Then extra 4 electron is there on oxygen, means 2 pair. Then they can give, okay, they can give to the electron deficient molecule, okay, or a species. Then here H2O can be have. After that NH3 also electron donor. H2O also they can donate. OH minus also it can donate. OH minus. Here you can see OH minus is there. Means 1 electron extra is there. Then here actually 9 electron is there. 9 electron you can tell. That's why it's unstable. Because 1 bond is there, OH. Okay, then 2 electron is there, 2 electron, and 6 electron, 3 pair is there here. Actually what is happening, that H plus is there, OH, then H plus will go. H plus, they require only 1 electron. H plus means what? Hydrogen required only 1 electron, H plus. Then that oxygen is giving 1 electron. That's why after giving the electron, on OH 1 electron will come, 1 negative. Then 7s are remaining there. 7 oxygens are remaining there. 7 electrons are there. Okay. 7 electrons. Then here actually this H plus, here you have to understand, H plus means hydrogen has only 1 electron, but its maximum capacity is there to have 2 electron. Maximum 2 electron hydrogen can have. Then oxygen has given a pair of electron. To hydrogen. But here maximum capacity, if H is coming as a H plus, means hydrogen has no electron at all. H plus means its capacity is of 2 electron. Now not a single electron is with hydrogen. What was it was having, it has given to others. Then that's why it is H plus. Then oxygen will give a pair of electron, full pair, 2 electron will give to the hydrogen. Okay. Then oxygen has given 2 electron to hydrogen. Then now here actually this OH minus is coming. Minus means here it is telling negative. Hydrogen has taken electron. But it can accept 2 electron also. If hydrogen is coming only as a H plus, no electron, in that situation it will accept 2 electron when there is no electron. But if hydrogen has 1 electron, and when it is coming near the oxygen, then it will give only 1 electron. Oxygen will give only 1 electron, because 1 electron already it is with hydrogen. Then only 1 negative sign will come, because it has taken only 1 electron from hydrogen. Okay. Then here you can see that now total number of electron, one electron given to hydrogen. Hydrogen was having their own electron 1. Then hydrogen is now okay 2 electron. But it has taken 1 electron only from the oxygen. Then now 7 remaining, you can say, electron will be on oxygen. Then 6 electron, oxygen has 6 electron. Then 6 plus 2, 8 electron. 6 plus 2. Total 6. Oxygen has 6 electron, 1 has given. 1 has given to hydrogen. Then now 5, not 6, 5 is remaining. 5 is remaining. And but here you can say minus is there, because octet is not full octet for both, it is not completed. Because oxygen has 6, hydrogen has only 1. Then total is 7 only, then 7 octet is not completed. That's why extra electron, 1 electron is taken by the H2O is forming, the OH minus, that will come H plus. In that situation, that's why, because that H plus, that H has lost the electron and OH has taken. That's why it is becoming OH minus. OH minus. Okay, then no problem. Here I have told about the these things, OH negative. Then here it can, OH also can donate a pair of electron. That I wanted to tell you. OH minus can also donate 1 electron. Then to whom they can give? Then who is lagging behind at electron deficient species? It will give to that species. Then hence I told you example of, you can say, this species like H2O, NH3, OH minus, etc., which can donate a pair of electron, can act as a Lewis basis. Okay, this I have told you about the this Lewis 3 concept. I told you Bronsted, Lewis acid and bases, concept of Bronsted, Lowry acid and bases, and first one I told Arrhenius concept of acid and bases, and third one I told about the Lewis acid and bases concept. Now just I am solving some problems related to acid base. Okay, the question is asked. Objective type, multiple choice question, these are asked. Then now actually I am telling a full concept, hence only on this concept you can answer all multiple choice question, MCQ, not question wise you have to require to learn. Okay, concept always, whatever I have discussed till date, all 6 chapter, last chapter is there in part 1. Then full concept I have discussed, and only on that basis all multiple choice question you can answer. Now here you can see, here also you can solve it, this problem on the basis of concept what I have taught you. Now you see, question is there, means problem, what will be the conjugate bases for the following Bronsted acid? Following Bronsted acids, HF, H2SO4 and HCO3. Okay, carbonic acid. HCO3 is called carbonic acid. 3 acids they have given. HF, hydrogen fluoride, H2SO4, sulfuric acid, and HCO3, carbonic acid. Then question is that what will be the conjugate base? Conjugate base they are asking for these 3 acid. Then how easy this question is there? HF, one by one you take HF. Then what will happen? HF is acid. Then after donating H, after giving H, what will remain? F minus will remain. H plus it will go. Then because H plus is losing, then this is actually acid, and F will be conjugate base. Okay, the conjugate bases should have one proton less in each case, and therefore the corresponding conjugate bases are fluoride ion. In case of HF, conjugate base is fluoride ion, negative charge F minus anion. Like that way, for H2SO4, H plus it will give. Then what will remain? HSO4 minus. HSO4 minus, that is the conjugate base. And for this HCO3, after losing one H, only one H it will lose. Okay, consider, keep in mind, because they are differing only by proton, H only one proton. Then HCO3, H plus will go, then what will remain? CO3, 1 minus. Then this is the conjugate base. Then I told you in the case of HF, F minus is the conjugate base, H2SO4, H plus will go, then HSO4, 1 H will be there, HSO4, 1 minus will be the conjugate base, and CO3 minus HCO3, H will go, H plus, H plus, then CO3, 1 minus, that is a conjugate base. See how it was easy, because now you are knowing, that's why you have solved very easily. Now this another problem I am telling you. Write the conjugate acids for the following Brown-Stead bases. Now Brown-Stead bases they have given. Okay, then what are they have given? NH3 1 minus, NH3 1 minus, NH3 second, and HCOO minus. Three they have given, three bases they have given, and they are asking write the conjugate acids for the following bases, Brown-Stead bases. Then NH2 1 minus, second NH3, and third HCOO minus. Then what you have to do? Very easily you can write that the conjugate acid should have one extra proton in each case, and therefore the corresponding conjugate acids are what? Extra one H you add in that all, because they are differing only in one H plus. Then here you are talking about the conjugate acid. Bases they have given, acid they are asking. One extra H you add in all. Then what will form? NH3 minus 1 minus was there. Then 1 H plus you add. Then plus minus will be neutral. It will come NH3. And second is NH3. Then H plus you add. Then it will become NH4 1 plus. And third HCOO 1 minus is there. Then 1 H plus you add. Then HCOOH. This is the, you can say, acid. And it form NH3, NH4 plus HCOOH respectively. This is the answer. Okay. Then I have told you this is very easy. One H only you have added. All become acid. When one H will go, all will become base. In Brown-Stead Lowry, this thing, and Stead-Lowry concept, that is the only difference of H plus. H plus, that you keep in mind. H plus difference. If it will go, then it will form base. If it will accept, it will come acid. Now third example, third problem I am telling you. This is also very interesting. The species H2O, species H2O, a question given, the species H2O, HCO3 means bicarbonate, HCO3 1 minus, HSO4 1 minus and NH3 can act both as brown acids and bases. Bronsted Lowry acids and bases, you can tell. For each case, give the corresponding conjugate acid and conjugate bases. This question is also a very important question. That a question they have given, a species they have given, that is the H2O, means water, HCO3 1 minus, HCO3 1 minus, that is the bicarbonate HCO. Actually H2CO3 is carbonic acid, H2CO3, but 1 HCO3 minus means bicarbonate. Okay, and HSO4 1 minus. They have 4 species they have given: H2O, HCO3 1 minus, HSO4 1 minus, and NH3. They are asking what is conjugate acid and what are the conjugate bases. Both they are asking. One by one you can come. First you can say tell about the conjugate acid of this species, given species. First you write conjugate acid. Then I told you, don't forget that there is a difference of only H plus. Okay. Then if you want to acid, conjugate acid, then you add 1 H plus, then H2O plus 1 H plus, then it will form H3O plus. That is the conjugate acid, because it is accepting 1 H plus, means proton. Then like that way other also you can add. HCO3 1 minus is there, H plus you add, then it will become H2CO3, means carbonic acid. This is the conjugate acid. Third one, HSO4 1 minus is there. Then that HSO4 1 minus is there, add 1 H plus, it will form H2SO4. Okay, and fourth one is there, NH3 plus 1 H plus, then NH4 plus. Then these are the conjugate acid. These are called conjugate acid. Now if you want to write conjugate base of these species, conjugate base, then remove 1 H plus, and what is remaining, that will be the, you can say, base. Now from the given species you remove H plus, then H2O, from the H2O you have removed 1 H plus, then OH 1 minus is remaining, that is the base, conjugate base. Again from the HCO3 minus 1 minus you have removed 1 H plus, then only CO3 2 minus will be there, then this is conjugate base. HSO4 1 minus is there, again remove that H also, H plus removed, then SO4 2 minus, again this became conjugate base. And the last one was NH3, then from NH3 you remove 1 H plus, then what will remain, NH2 1 minus, because H plus gone, then NH2 minus 1 minus will remain. Okay, NH from the NH3 H plus gone, means leaving their electron, leaving their 1 electron, then that's why NH2 become 1 minus. Then these are the conjugate bases. Then it is very easy. One column you write a species, name of 4 species according to the question, other column conjugate acid you write. After that you can say adding H plus, it becomes acid. Now all 4 you write in one column. Third column you can make, and from that you remove H plus from the species, given species, then you will get conjugate bases. Then this I have told you about the these things, problems, third problems. One more problem is there, last problem, that is also very very important, and multiple choice questions. multiple choice question actually this they will ask this type of question is that problem classify the following species into Lewis acid and Lewis bases and show how these act as such. Okay, classify the following species. They have given 4 species. Classify the following species into Lewis acids and Lewis bases. Which one is out of 4? Which one is Lewis acid and which one is Lewis base? You have to differentiate. You have to find out of 4 which one is Lewis acid and which one is Lewis bases. Then first is HO1 minus. HO means hydroxyl ion. OH minus you can tell. Then what is this hydroxyl OH1 minus? It is what? Lewis acid or Lewis base. Then already told you OH can donate 1 pair of electron. That's why it is base because it can donate 1 pair of electron. Hydroxyl ion is a Lewis base. Why? As it can donate electron pair electron. Now second, fluoride ion F minus. Then fluoride ion acts as a Lewis base because it's a negative charge. Negative means it can donate electron. Then fluoride ion acts as a Lewis base as it can donate any one of the 4 electron lone pair because this fluoride ion F minus 1, then fluorine, you know, the 7 electrons are there, 1 minus is there, means 8 electron is there total. Then they have 3 lone pair of electron, fluoride ion. Then they can donate 1 pair or 2 pair also. Then fluoride ion is you can say Lewis base. And now third one is H plus. What it will donate electron? It can accept electron. That's why it is Lewis acid. H plus, it can 1 pair it can accept because H plus means now as hydrogen has no electron, hence 2 electron it can accept. Then it is accepting a pair of electron. That's why it is acid. Then H plus is acid. And fourth is BCl3. Already I told you, boron trichloride, boron trifluoride, all are boron is lacking electron. Okay, electron deficient. Hence it can accept a electron a pair. That's why it is acid. BCl3 acts as a Lewis acid as it can accept a lone pair of electron from the species like ammonia or amine molecules. Like that, many things it can accept. That's why it is acid. This type of many questions are asked in all examination, medical, engineering, or even in the other exams also it is asking. Today I am stopping only here. Next class again we will meet with new topic. Okay, thank you.